It's an open source 8-bit game console like none other, and there's not an FPGA in sight. This is the GameTank, and today we're going to make one and see what it can do. There's been a few different efforts to create a modern 8-bit system with off-the-shelf parts. But one thing that all those projects have done is use more powerful, modern programmable logic chips for some aspect of the system. But a talented maker named Clyde Schaffer took a different approach. Clyde designed this game console, the GameTank. It's an 8-bit system that's based on the popular 6502 processor, which is still being produced today by Western Design Center. And amazingly, the entire system is built with common, off-the-shelf components that are still in production. There's no microcontroller, CPLD, or FPGA anywhere in this system. Instead, you'll find a real 6502 CPU running at 3.58 MHz. This CPU has access to a 16-bit address bus, and just like any other 6502-based architecture, all the hardware that the CPU talks to is mapped into that address range. The upper 32 kilobytes from addresses 8000 through FFFF all map to the cartridge slot, so game cartridges can place 32 kilobytes of data on the bus for the CPU to access. But games aren't limited to just 32 kilobytes. The GameTank also has a memory banking architecture that's built into the cartridge design. This allows cartridges to include up to 2 megabytes of storage for graphics and game code. The upper 16 kilobytes of the cartridge address space are mapped to a fixed region of the cartridge's memory. But the lower 16 kilobytes can be swapped out into 127 different memory banks, which can be accessed through the onboard VIA chip or Versatile Interface Adapter. For this, the GameTank uses a 6522 I/O controller, which goes hand in hand with the 6502. This is the same VIA chip used by early Commodore and Apple devices, along with some other modern 8-bits. The VIA controls an in-cartridge shift register that selects the lower 16 kilobyte memory bank. But alongside that, it's also responsible for handling I/O with external devices and peripherals. It does this in two places. First, it exposes an additional port to the cartridge slot, so a cartridge could incorporate a serial device such as a real-time clock chip. But there's also an expansion connector in the rear which exposes additional I/O ports. This expansion port is different based on which version of the GameTank you have. We'll talk more about the different revisions in just a few minutes. For audio, the GameTank uses a second 6502 CPU, which is basically an audio coprocessor. This additional CPU is clocked at 14 MHz, and that's the maximum rated clock speed for the modern CMOS version of the 6502. The audio coprocessor runs a sound engine that takes note data from the main CPU and puts it through a DAC circuit. Now, if you create a game with the GameTank's software development kit, there is an audio engine included that you can just use. The audio engine contains a 4-voice FM synthesizer with 8 different instruments. You can sort of think of it like a slimmed-down implementation of an OPL chip. Now, where things get really interesting is the design of the video subsystem. Video chips are typically the toughest part to source for modern 8-bits. Back in the early days, companies would produce custom graphic chips with different features that set them apart from competitors. And this has been an ongoing challenge for collectors and restorationists because these chips are getting increasingly difficult to find replacements for without going the FPGA route. But rather than a graphics chip, what you'll find on the GameTank is a bunch of common off-the-shelf 74 series logic ICs. These chips work together to output a 128 by 128 pixel image through a standard composite video connection. But the GameTank doesn't just require you to bit-bang pixels into a frame buffer. It has many of the conveniences that a developer would expect to find inside a graphics chip, including hardware sprite support. To achieve this, there's a 512 kilobyte SRAM chip, which can hold 8 256 by 256 pixel pages of sprites. Unlike some other 8-bit systems, the GameTank sprites aren't a fixed size, so you can define both their width and height. The GameTank splitter circuit copies sprite data from memory into a frame buffer independent of the CPU. There's even hardware support for sprite flipping, as well as transparency. For color, the GameTank uses 1 byte per pixel with a fixed palette of 200 unique colors. Any number and combination of colors can be used in a sprite, so the graphics can look quite good despite the low resolution. This is all very impressive for a device without a video chip. Alright, I'm excited to try this system out. So let's go ahead and build one. Now, there are 2 variants of the GameTank's hardware. If you're wanting to build it yourself, you'll likely have an easier time building the through-hole version. But before you rush out and start buying parts, there are a few things that you'll want to know. First, while most of the build is through-hole, there are a couple of surface mount parts. The video buffer requires surface mount soldering, as well as the cartridge and controller depending on which options you choose. Second, if you're wanting to build peripherals or add-ons, you're going to be more limited with the through-hole version. And that's because the expansion port I mentioned earlier only breaks out some of the VIA chip's I/O pins. The surface mount version, on the other hand, provides access to many more signals that you'll likely want to use in an expansion peripheral. But the main challenge is that the current revision of the through-hole design uses 2 memory chips that have unfortunately become obsolete. You can find them in various secondhand marketplaces, but there is a limited supply out there, so you'll want to make sure that you can acquire those chips before you invest in all the other through-hole parts. The alternative, however, is the surface mount variant of the GameTank. It may be a little more challenging to build yourself, but it does overcome the chip availability challenge and gives you full use of the external I/O pins. This is also the variant used for the pre-assembled GameTank that you can purchase from the crowd supply campaign. But as you can see, I went with the through-hole version for this video, because I figured this is what most people would be building themselves. There is one huge benefit to doing a through-hole build, and that's the use of chip sockets. Now, you don't have to use them. If you want to save a little money, you can just solder the chips directly to the board. But with the larger number of ICs in this build, you're bound to make a mistake, so having everything socketed is very helpful. Now, to build the GameTank, you're going to need several circuit boards. And for that, we have some provided by this video's sponsor, PCBWay. As you know, PCBWay is my preferred provider of circuit boards for my various projects. Their PCBs are high quality, and their turnaround times are super quick. And if you need help during the ordering process, PCBWay's staff of knowledgeable experts is here to offer support. For the GameTank, you need to order 7 separate boards. The largest one is the CPU board, and that houses the processor, system RAM, address selection logic, and input processor. You can think of it as the GameTank's main board. The other large board with the hole in the middle is the AV board. This PCB contains the audio circuitry as well as the composite video logic. In addition to these, there's a separate power board. Now, you could feed 5 volts directly into the CPU board from a regulated power supply, but Clyde included this little power board in case you want to use a higher voltage PSU. You also need this tiny little video buffer board. Now, I inadvertently missed it when I placed my order, so Clyde ended up sending me one of his extras that he had lying around. There's no built-in ROM on the GameTank, so you're also going to need a cartridge. Now, ideally, you want to use hard gold for the edge connector on these boards, but that's really expensive. So I did the next best thing and got mine with an ENIG finish. I also had PCBWay bevel the edge, which helps with wear on the cartridge pins. The GameTank actually works with standard Genesis or Mega Drive controllers, but you can also build your own. If you decide to do that, then you'll need a controller PCB as well. And finally, you'll need to build a cartridge programmer, so you'll need a PCB for that. Okay, we have our boards, and there's a lot of parts to solder. There are nearly 100 chips on this system, so I'm not going to go through each one individually. For this build, I'm going to just follow the build guide on the GameTank website. Okay, we'll begin the build by first soldering all the decoupling capacitors for the chips. Next, I'll do the resistors. And then the electrolytic capacitors. Then we have all the dip sockets. There's 31 of these in total, ranging from 8-pin all the way up to 40 pins. Now, I blindly followed the build guide here, but if I were doing this again, I would have soldered the sockets before doing the electrolytic caps. It would have been easier to lay the board flat against the table. There's also 2 PLCC sockets. And then we have these 2 interconnect sockets. Now, these are easy to install backwards, and they would be a huge pain to remove intact, so I double and triple check the orientation before soldering them all the way. We'll also need to install the audio and video ports, as well as the header for the video buffer module. Then we can insert all the 74 series logic chips. This LM358 is an op-amp for the audio. Next, we have this larger PLCC chip. This is dual-port memory that's used for video RAM, which is one of the obsolete chips that I talked about earlier. And this is the other one, another dual-port SRAM chip used for shared audio memory. Finally, the last chip on this board is the 6502 audio coprocessor. Okay, we can set the completed AV board aside and start building the CPU board. The process is similar. We'll start off with the 63 decoupling capacitors for all the chips. Then we can add the resistors. And the 1 electrolytic capacitor. And like the other board, we'll add all 59 of our sockets. Then we'll solder on the controller ports. Followed by the interconnect sockets. Again, it's easy to get these backwards, so you'll want to make doubly sure that the orientation is correct before soldering them in. We also have a couple of Molex headers, and these are for the power LED and the reset button. Now we'll set the CPU board aside for a moment, and we'll need to assemble the power module. This is a pretty simple board. It just has a voltage regulator, a few passive components, and the barrel jack connector. Once that's assembled, we can solder it to the back of the CPU board. Alright, now we can go ahead and insert all of our 74 series logic chips. And here we have the SRAM chip for the system's general purpose memory. This chip is our 512 kilobytes of Sprite RAM. And of course, we have our 6502 central processor. And the 6522 VIA chip. For the case, I 3D printed Clyde's shell design in 2 different colors. The CPU board goes in first, and then the AV board connects to it using the interconnect ports on each side. We can then attach the power and reset buttons to the lid. And those plug into the Molex connectors on the CPU board and the power module. To hold it together, we'll use 4 20mm M3 screws. And then we can finish it off by attaching the rear power port cover. And of course, we need some rubber feet. Alright, here's our completed GameTank. And it certainly does resemble a tank. But we can't use it yet. And that's because this system doesn't have an internal ROM. This isn't unique when it comes to 8-bit game consoles. Many of them didn't have ROM chips built in. So we can't really test the CPU and the overall system functionality without a cartridge. However, since the video circuit runs independently with its own logic, we should be generating a composite signal even if the CPU isn't working. So we should be able to turn it on and see something on the display. And as you can see here, it looks like we have some random pixels. So that proves that at least the video portion of the AV board is working correctly. The reason we see these random colored pixels, by the way, is because the video circuit is just dumping the random data in memory out to the display. But to really test the console, we'll need a cartridge. There are 2 different types of cartridges currently available for the GameTank. First, there's an EEPROM cartridge, which is pretty simple to build. It uses an EEPROM chip for storage, and that only gives you a maximum of 32 kilobytes. There are some games that can fit on an EEPROM chip, but most of the games require more space. So if you want to play every game, you'll want to use this 2 megabyte version of the cartridge. It's a little bit more challenging to assemble because it uses surface mount parts, but with a little patience and plenty of flux, it's completely doable. You'll notice that there's 3 pads on the back of the cartridge. These pads connect to the right enable pin on the flash chip, so before any data can be written, we first need to bridge these top 2 pads with solder. And of course, we need a cartridge shell to finish it off with. Now, before you can use the cartridge, you'll first need to program it. And for that, you'll need to build a cartridge programmer. There are two options for this as well. First, you can go the all-in-one route and build a programmer that uses a custom PCB. This design uses an AT chip that runs an Arduino sketch which does the flashing. However, I ended up going the simpler route and assembled a cartridge programming shield designed for an Arduino Mega. Once the Arduino sketch is loaded onto the Mega, you can connect to it through a serial interface, and that gives you a few options. I first ran the test command to make sure the cartridge was working correctly, and that came back successfully. There are also commands for transferring data, but that's not something that you'll want to do manually. Instead, there's a flash program that you can run. After using it a few times, I felt that it was a bit arduous to download games and load them through a command. So to make this easier, I ended up creating an application that pulls the list of games from the GameTank website and programs them directly to the cartridge. I've posted this app in a GitHub repo and included a link in this video's description. The GameTank website catalogs the games that have been developed by the community thus far. Before you decide if you want to give a game a semi-permanent home on a cartridge, you can click on it and play it in a web-based GameTank emulator. After trying several, I narrowed the list down to a few that I wanted physical copies of. So I programmed a few cartridges with the Arduino Mega programming shield. And of course, I had to make some labels as well. Alright, with a programmed cartridge now in hand, we can go ahead and test the GameTank. And as I turn it on, you'll notice that the power button is actually reversed. The console's turned off when the button is pressed in. I thought maybe I ordered the wrong switch, but it turns out that it's caused by this particular revision of the power module. This was changed in a later board revision, so if you purchase a GameTank through Crowd Supply, it'll have the standard button behavior. And as you can see, the system reads from the cartridge correctly, and the game fires right up. You'll notice that I'm playing with the Sega controller. The GameTank supports both the 3 and 6 button Sega controllers natively, so you don't really need to make an official GameTank controller. Of course, I did have to try out the native controller, so I went through the process of building one of those as well. And it works perfectly fine. I do think, however, that I'll be using the Sega controllers with my GameTank because they do feel a little nicer. One other thing I do want to mention is when I connect a controller, the port wiggles a bit. If you look under the board, you'll see that the mounting posts can't be soldered to the PCB because there's no copper around the mounting holes. I asked Clyde about it, and he did change that in the later design. So this won't be an issue if you buy a GameTank from the Crowd Supply campaign. Aside from that, the system works well overall. The game I'm playing here is called Accursed Fiend, and it's a Zelda-style dungeon crawler. There's not much of a story element to it, but the game mechanics are great, as well as the graphics and the audio. Another game I've really been enjoying is this puzzle game called Katachidasu. There's also this fun little open-world building game called Minecraft. And of course, I have to mention Ganymede. This is an action-adventure game that does a great job of demonstrating what the GameTank is capable of graphics-wise. It's really quite impressive for a 6502-based console. Well, I have to say, the GameTank was a very fun build. The assembly came together nicely, and I've actually been playing it a lot more than I thought I would. The cartridges are perhaps my favorite feature. I've really been enjoying having a physical library of GameTank games that I can build up over time. I think there's a lot of potential to do some interesting things with this console. I have some ideas for expansion modules and peripherals that I can make for it, so I may come back in the future with another GameTank video. Be sure to subscribe so you don't miss future episodes. I want to thank Clyde for answering all my questions and for helping me obtain a couple of the parts that I needed for this build. If you're interested in this project and want to purchase a pre-assembled GameTank, you can purchase the surface mount version from Crowdsupply. And of course, a big thank you to PCBWay for sponsoring this video. If you want to build one yourself, be sure to get your quality GameTank PCBs from PCBWay.com. I posted links to some other resources in the description, including the build guide that I followed, Clyde's GameTank YouTube channel, and the GameTank Discord server, so be sure to check those out as well. Alright, that's all I have for today, so I'll see you next time. But, as always, until then, go make something cool.